the program basically composed of three parts, three major functions. The first one is process data, then it will find the position, then it will draw the ball. So because the data from the accelerometer it gives you numbers, and those numbers are represented by millivolts, which you have to process it to some kind of sensible data that we can use. So the first part, processing data, is basically take the readings and process them into angles. But right now, because the lack of technical definition for the accelerometer, we use the set of definitions that we find online and come up with a set of angles that's working. But the angles has to be recalibrated, and the positioning part is going to do this. It's basically at first what I did is to measure every position, every extreme position, for example 90 degrees or 180 degrees, and take the readings and then map them out. After I map them out, I start with the finding position function. What it does is basically try to locate which row and which column the LED should be light up. Okay. So after finding the position, so before in the process data part, it used our cosine function to get the angle. And right now, what we did is, at first we get the three readings, like the angle for X and for Y and for Z, and then we process them into since the display is 8 by 8 display, we process them into a number, either 1 or 2 or 3 or 4 or 5 or 7 or 8, and then we use a cosine function to calculate which one we should use, since it's mapped onto a circular position. So after I find the position of the data, like which row and which column the LED should light up, I began to use a function to draw the ball. The ball consists of 4 LEDs light up at the same time. So it is a little bit complicated because you have to consider the whole 8 columns of LED to be connected. So when the LED goes to 7, number 7 starts from 0, which number 7 is the last LED. LEDs at number 0 should be light up at the same time, but the program is a little bit complicated, but we figured that out. And if the position, the balloon goes to the top of the LEDs, which starts from 0 to 7, the LEDs, the balloon, the 4 LEDs that are supposed to light up doesn't go through at the beginning, but right now they're working now, so that's a part we did. And at last there is a test program, basically light up one LED on each row, and it's gonna try to see if the lines, the rows are connected. We only use this when we try to debug the whole umbrella.
For the socket part, we used 8 by 8 LED, so it's 64 LEDs, and we do it horizontal and vertical. It just end up like a web like this. After that, we have to sew it on. And after that, we have to connect all the wires from the top to the bottom because the Arduino is on the bottom, and also the sensor. So just that.
You can. You need to tilt a little bit more. Yeah. You don't have to shake it. Just tilt it.
Maybe more, a little bit slowly. Yeah, the umbrella's kind of heavy, but it was fun to play with. Like, it gives you something to do when it's really raining. Yeah, cool project. I think if these things can be used outdoor, it will be so fun. Cause like normally when we are using umbrella, when it's raining and maybe no one beside you, it will be like kind of boring and stuff. And then if we're holding this umbrella, we can at least play with it and make yourself more interesting while you're walking alone or something.